Hello, everybody. Welcome to our RagHack live streams.
RagHack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RagHack. And now a word from our friends at Reactor.
Hi, everyone. Thank you for joining us for the next session of our RAG hack, Building RAG Apps with Langchain4J. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor YouTube channel. With that, I'd love to turn it over to our presenter. Julien, thank you so much for joining us today.
Hi, thank you. Thank you for having me. I'm very happy to be again working with a Reactor at Microsoft, and very happy to share with you everything about Langchain4J and building RAG apps, RAG applications in Java. Thank you for sharing my screen. That's the next thing I was going to ask you. So today we're going to talk about Java. So I hope you're all Java developers. If you don't know Java very well, don't be afraid. It's going to be simple Java. We are going to focus on AI and RAG. And when you want to build AI applications in Java, you've got different tools. Langchain4J is one of them. That's the one I will focus on today. You have another session later on Spring AI, which is basically the competitor from Langchain4J. We can talk maybe at the end and compare both of them. But I would say for a simple usage, they're going to be very similar. They are going both to help you develop an AI application in Java and more specifically a RAG application in Java, because it will provide you with lots of tooling and utilities which make you very productive, and you will not lose time, writing, let's say, boilerplate code to link everything together. So let's get started. So this is a website for Langchain4J if you want more information on Langchain4J. It's fully open source. It's on GitHub. You can go here to the GitHub repo, and you can contribute. It's really a community project. So I'm one of the contributors, and I contributed mostly on everything on Azure, like Azure OpenAI, Azure AI Search, that kind of things. But there is support for many other AI tools and competitors from Azure. You can also use Google or AWS with Langchain4J. That's also one of the benefits of Langchain4J. It's like it's neutral, it's community driven. So when you're with Langchain4J, it opens you the opportunities to work with all the toolings that are available from the different companies that push AI, like Microsoft. But you are not tied to a company. That's very good as a developer because it's open source and it's free, and you can have access to all those tools very easily and in the same way. So once you've learned, like what we're going to do today, once you learn how to use it with Azure, you know how to use it with other technologies. In fact, that's what we're going to do a little bit, because we're going to use it inside Docker, so locally, and we're going to use it inside Azure. So you will see that we can switch very easily from one tool to the other by just some configuration. So not really any Java code. Let's get started with my presentation. So Langchain4J, what we just said, it's a Java version of Langchain. Oh, no, sorry, I didn't say that, I forgot. Langchain, it's the most popular tool in Python to do AI. And Langchain4J is the Java version of Langchain. It's, let's say, similar, but it's in a different language and built by a different community. The name is the same, but the community is, and everything else is different. Just the objective is the same. The goal is to simplify the creation of applications using LLMs in Java, and again, it's fully open source. Why do you want to use it? You want to use it for three reasons here. The first one is that it gives you an abstraction layer above all the APIs from the different providers. And you will see that it's very useful for you because once you know how to use Langchain4J, you have access to all those tools for basically for free because you know the Langchain4J API. It's also very good for testing or for moving from one solution to the other because you've got that layer of abstraction. The second thing is that it gives you an easy integration of those different APIs to build more complex applications, including RAG applications. You will see how easy it is. And last but not least, it gives you lots of tools and utilities. We will see the main ones in a few minutes. When you build AI applications, you always want basically the same things. And Langchain4J has got you covered. All of this is already included. So you don't need to code all this again and again. It's already provided for you by people who know what you really want, probably. You've got a nice image on the right from Java developers in Paris, because I'm a Java developer and I live in Paris. This was done with Langchain4J and Azure OpenAI with, let's say, a couple of lines of code. And that will be my first demo. If you want to do those demos with me, I mean, you should, because that's the idea, is the GitHub repo. In this GitHub repo, you've got all of the code that we're going to use. You've also got this presentation. So you've got the link here. You even got a QR code if it's useful for you. And I encourage you to go and fork this and start playing with me. Again, we're going to use Azure, but we're also going to run everything inside Docker. So if you don't use Azure, you can also run everything locally on Docker easily and for free. What we're going to do with a demo, so it's a set of 11 demos. We're going first to do the basic usage of Langchain4J, and we'll start with image generation. As I just said before, we're going to do an image similar to that one. We'll do simple text generation, well, let's say the basic things that you would do with AI. We'll have a look at the commonly used utilities that you will want to use with a tool like Langchain4J. And then we'll go in the, let's say, core of the presentation, building a RAG application with Langchain4J. We need to have the first demo just to introduce everything, but then it will quickly all be linked together to do the RAG application. We'll see how we can ingest data in the vector database, or can we use a vector database, and that's quite easy. And we'll finish with, well, really one application, and we'll use something called EasyRag. So EasyRag is specific to Langchain4J, and that's why you should use Langchain4J and you should use Java, is because here you've got something a lot easier to get you started. So if you want to build a RAG application, you can do everything from scratch and you will have hundreds of lines of code. You can use Langchain4J with all the configurations that you want. You can detail everything. It's very configurable. That's really nice. But then if you want to do a RAG app, which is, I would say, normal, nothing fancy, well, with EasyRag, you will see that in very few lines of code, you have everything provided for you, and you will get up to speed very fast. So for a demo, for a hackathon, like what we're supposed to do in this week, it's perfect for a hackathon. It gets you started very fast, and then you can tweak and improve stuff later. But the first version, well, you're going to have it running in a few minutes, which is what we want for a hackathon. If you want to run the demos that we're going to do, you basically 3 ways to do them. You can run them in the cloud, which I will do first. So you can run them on Azure. You will have access to all of our advanced models. You will have great performance because we've got wonderful GPUs. Everything is wonderful, but it's in the cloud. If you want to test and not have any rate limiting, nothing to pay, well, you can run also everything inside Docker. That's also what we will do today. And if you want to work also locally, instead of using Docker, you can also run some stuff directly on your machine. We will see it's more performant. It's a little bit more annoying than running everything inside Docker, but you've got better performance. It will be a way also for me to show you how those tools work with a GPU and why it's so important to have a GPU to do AI. And why maybe it's important to run them on Azure because we've got good GPUs. I'll do this slide later when we'll arrive at the RAG part of this demo. Just looking at the chat, is everything okay? Yeah. Not seeing any specific messages. Yeah. I believe everything is okay. Let's get started and let's get to code. So if you want to do like me, you just take the application that we have here and you fork it. and then you open it up in your IDE, like what I'm doing now. It will start with a README file. By the way, the PDF presentation that I just used is right here, so you also can see the presentation. This project is a simple Spring Boot project. I hope you all love Spring Boot. I mean, if you're Java developers, you probably know Spring Boot. It's a most commonly used framework, and that's why I'm using it here. And in that project, we're going to have two profiles. In Spring Boot, you've got profiles. We've got a local profile and an Azure profile. By the way, I'm going to start with Azure. So the Azure profile uses Azure and its different services. The local profile uses Docker, your local computer. Let me run it with Azure. And this is going to create an application running on localhost 8080. And here you've got access to all our demos. And well, we'll do the first one. So the first one is image generation, as I said. And let's click on it. Let's have a look at the image that is being generated. And then oh, it didn't work. Wonderful demo effect from the start. Yeah, shouldn't be null. So you can see this is all live. Yeah, this should all be good. Yeah. What did I do wrong? Come on. Yeah, it's running. I have no idea why the first one didn't work. I just restarted my server. Maybe I had something old running. Here it is. So not a big demo effect. Let's open it here. And we've got an image of a cup of coffee in Paris. And let's have a look at how I did that. And was it complicated or not using Langchain4J. So my application, I've got like two sets of files. I've got some configurations, and I've got some then real code to use that configuration. Let's have a look at the configuration here, and let's have a look at the image model configuration. So this is a Spring Boot configuration. It uses the Azure profile. You saw me using it. And it needs, let's say, a few lines of configuration. Here we're telling it, I want to use Azure OpenAI. Here is my endpoint. It's injected here. It's a URL. Here is my API key, which is injected also from here. Here is the model I want to use. I want to use DALL-E3, which is for generating images. I want to log requests and responses. If we have a look here, at the console, we can see everything is logged. It's very useful if you want to debug. You can see we went to that URL, we posted some question, and we had some answer. Very good for debugging. And I'm basically building that image model. The image model, that's an interface from Langchain4J. So if you remember my presentation, I said you've got an abstraction layer on top of all the different cloud providers or providers of AI services. Well, image model is the interface from Langchain4J, and we've got different implementation. And here I'm using an implementation, of course, from Azure. I'm using this one from Azure. So this is the implementation from Azure, but I use the interface. Wonderful. So if I go back here, I've got this configuration, which is specific to Azure, and which gives me back that interface, which is generic for Langchain4J. As you can see, the configuration is very easy. If you want to switch to other AI services, it's basically the same. It's a different implementation, but basically it's always the same thing. And the idea is that you've got that interface, and then you can play with it. And the way I'm using it, so here is my Spring Boot controller. I was using, if we have a look here, URL /1. So /1 is here. And so my question is, so I'm using Azure OpenAI, I'm doing this here. So my question is, I want a coffee mug in Paris, France. And I'm asking my image model, so what we just configured, the Spring Bean that we configured. Yeah, I just injected it here. So that image model that we configured just before, I'm using it, and I tell it, generate an image using the question, so a coffee mug in Paris, France, and then give me back the URL, which is what we got right here. And then, well, we got the image. As we can see, the configuration I had here was pretty simple. And then using it, here, I've got nothing which depends specifically on Azure. And I have everything with one line of code. So very easy to use and very easy then to switch different models. Like here I'm using DALL-E 3. You can use other models. Very easy to change the configuration, have another model, and then this code will still run, which is the goal of Langchain4J. It's giving you tools and abstraction layers so that you're very efficient at generating that kind of content. So that was the first demo, just an image. Now let's do something a bit more, let's say, interesting, because the image is fun, but like there's no real big business value out of this. So my second demo is I've got a question. Who painted the Mona Lisa? And I want an answer from my LLM. Let's have a look at how we did that. And so we were using here the Azure Image Model configuration to do images. To do chats, well, it's another implementation. Here it is. And if you look at it, it's very, very similar to what we just did. This time we want a chat language model and not an image model. We want to generate text. We've got a different implementation from Azure, still getting the URL, API key, the model you want to deploy. So here I'm using GPT-4o, logging requests and responses, very useful to debug what's going on. And then, well, it's configured. And then to use it, let's go to my second URL. So the question was, who painted the Mona Lisa? And how did I use it? I said, chat language model, generate from my question some content and put it in my web page. And I got the answer. The Mona Lisa was painted, blah, 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 blah. So very easy to use because we've got here a very, let's say, nice API from Langchain4J. And I'm not using directly the Azure OpenAI SDK. I mean, I use it underneath, but here I don't even need to know the specific SDK or the AI service I'm using. I'm using the interfaces from Langchain4J. We'll see that it's very useful afterwards when we do RAG and we will want to change models, play with everything. It's much easier to have those interfaces that help you than being, with the low-level APIs. By the way, I was using Azure. Let's have a look at how I can use it with Docker, so how I can use it locally. And we're going to change it right now and have a look at how we can switch. And that's the first, for me, the first real interest of Langchain4J. So we were using Azure chat model configuration. Now I'm going to use a local chat model configuration. So that one is another Spring Boot configuration using, another Spring Boot profile, which is local. So if you go here, it's configured with a local profile. And this one, so we're using another implementation, which is the OOLAMA chat model. It's got a different configuration, but it's still very similar. We've got a base URL, which is local, another model, etc. The configuration is a little bit different, like for logging requests and responses. As you can see, it's different because it's another implementation, but it gives you back the same interface, chat language model. So all I'm doing here is changing my implementation. I don't change the interface, so I don't need to touch anything here. This will still work, but it's going to use another implementation. Now let's run this. If you go to my GitHub repo, everything is configured here with a Docker Compose file. So let's run this. If you got Docker running, okay. So it's going to start a few services. It's going to run OOLAMA, which is basically the AI model we're going to use. I mean, it's what's going to run the AI model we will use. It's got a nice web UI, so it will be useful for us to see what's going on. And I'm also starting, but we'll use it later for RAG. I'm using a vector database here, so everything is ready just afterwards. So let's go to the web UI and see what this is. So OOLAMA is a great tool for trying out different models locally. So it runs here inside Docker. They're not installed yet. It's taking a few seconds to install. Just let me check. When it's run, it's going to run this. It's going to install two models. It's going to install Phi3, which is a model from Microsoft, a very small and efficient model from Microsoft, which runs locally. And it's going to install another model for embeddings. We'll see that a little bit later with RAG, and it will also install it locally. So it's installing those images, those models locally inside Docker. If I go back here, I think it's, yeah, here they are. So Fish3 is installed. It's a very small model. By the way, you can chat with it here. What's interesting with Fish3, it's very small, so it's going to be rather fast. And it's free and open source from Microsoft, so you can use it very easily in your tests or development systems without paying anything. If you have those new fancy Copilot PCs, that's also what you're going to have locally. Fish3 is a very good model for a small model. It's widely different from what I was using before. I was with GPT-4o. It's a large language model. It's very big. It needs lots of GPU to run. Fish3 is very small and uses a lot less resources. On the other hand, it might be not as good. But I mean, for testing or for something simple like what we're doing here, it's good enough. So that's why I'm using it. One thing you might have noticed, I said it was fast. It wasn't super fast, as you can see. Let me go back here and ask it. I don't know. Another question. It's answering me, but it's not crazy fast. That's because it's running inside Docker, so it's not using any GPU. I'm on a Mac, and Docker for Mac doesn't expose the GPU. So this is running fully on a CPU. We can see that even if it's a small model, it works, but it's not crazy fast. That's something we're going to improve just afterwards. But honestly, that's good enough. So let's get started. Let's run our demo again. This time using Docker. So here's my app, hopefully. Building. Yeah, you can see here that this is using my CPU a lot because my laptop is not running as fast as it used to run. If we go to the dashboard, if it's still running, you can see it's using a lot of CPU. Oh, sorry. Ollama is using a lot of CPU. Shouldn't be the web UI. Ollama is using 1000% of my CPU. I've got 10 CPU, so it uses all my CPU. That's why everything is slow. So it works, but it's not crazy. In fact, it's so slow. Hang on. Yeah, we can use it, but okay. Let me kill it. No, is it good? Is it good? Yeah, let me kill it because anyway, that was the next thing I was going to show. I'm going to kill Ollama. So you can run everything inside Docker. As you can see, it works, but it's slow. If you want better performance, my advice is to use it locally without Docker. Or if you have a PC on Windows, Docker has access to the GPU. There's a specific configuration for that. But typically on a Mac, you need to run it locally to have access to the GPU. So I'm going to run Ollama here locally. And I'm going to install, Ollama. I'm going to install Fish3 and Nomic embedded text. They're all running. And now it's running locally and not inside Docker. And you're going to see the difference straight away. It's going to be much, much faster. Anyway, my application started. Let's go back here. So that was the answer from GPT-4o, which is, again, very big, very good, excellent. And the answer is probably excellent. Now let's have a look at Fish3. When I was started, this time, again, same app, same controller, just a different configuration that this time talks to a local model. And here's the answer from Fish3. And usually, I haven't read it yet. Yeah, it's pretty good. For something, Mona Lisa is super famous. So even a small model like this is perfectly good for answering something like this. That's nice. We got the same answer. And as you can see, this time it's much faster than before. Again, we're running it locally and not inside a Docker. And the GPU makes all the difference. So here, another answer. I just refreshed. So we saw, let me go back here to my list of demos. We saw to do an image. We saw to do a simple question. Now let's go a little bit deeper and let's check those models. we're going to ask it a question. So like demo 3 reasoning. Let's have a look at my question first. That's something I love to do with those models, because that's how you know if they are good or not. So my question, which is a reasoning question, so it's a little bit complex. Maria's father has got 4 daughters. So there's a trick. Maria's father, of course, one of the 4 daughters is Maria. Maria's father has 4 daughters, spring, autumn, winter. Usually bad models will fail as this. They will say, oh, there's a list, spring, autumn, winter. The 4th one is going to be summer. And so Maria's father has got 4 daughters, spring, autumn, winter. What is the name of the 4th daughter? It's a way to try to trick an LLM. If it's not very good, it will answer you summer. If it's good, it will answer you Maria. I'm already in Fish3. So GPT-4o, I mean, we can test it, but it will answer that easily because it's so good at, let's say, complex reasoning. Something like this, there's no issue. Here for Fish3, which is a very small model, again, we can have a duped. Will it be able to do that? And we can see that, so it's not that good this time, because my father has got 4 daughters. That's not the first time it does that mistake with me. It says, regardless of how many sons Maria's father might have. So it doesn't see its daughters, it says its sons. Like, it's a little bit weird. Still, usually it's good. As Maria is one of the children, Maria should be considered the 4th daughter. So again, Fish3, for a very small model, it's quite good at reasoning. It's not as good as GPT-4o, but even for something a little bit complex like this, it does the job. So for developing, testing, maybe even for production, good enough, which is wonderful because like we can run it here easily for free locally. Sorry, I see I have a question. Does the demo use Spring Boot because of its popularity or its support for Spring Boot more match? Oh, so very interesting question about Spring Boot. Basically, I have the same workshop with Quarkus. They both work the same. There is a stronger tie with Langchain4J with the Quarkus community. So in fact, Langchain4J might work a bit better with Quarkus. And Spring AI, which is done by the Spring team. So Spring AI is a competitor to Langchain4J. And again, there's another session with Mark Eckler from my team about Spring AI. Spring AI will work much better with Spring. So whether you prefer Spring or Quarkus, you've got, let's say, a tool that is maybe more suited to it. Then for what we're doing here, I mean, Spring Boot works perfectly well for this. And I'm using it mostly because of its popularity. There is just far more people knowing Spring than Quarkus. So when I do a demo like this, I tend to use Spring just to have more people understanding what I'm doing. They both work the same for something like this. By the way, there's a specific Spring Boot support for Langchain4J, which is also done by somebody from Microsoft. So you have, instead of configuring, so I'm configuring here my Spring Boot beans manually. I like to do this because it's easier to understand. But we have also support for, Spring Boot properties. And so you can configure them here directly, which is a lot easier and which a lot of people might prefer. I'm just doing the, let's say, a bit more detailed configuration to explain better. But yeah, both of them will work the same here. There's nothing really specific about Spring. It's mostly, I'm mostly using it because that's what most people know and nothing else. So what did we do? Yeah, so reasoning. So again, Fish3, quite good for reasoning. Not perfect, but good enough for our test. Now we've done the basic demos. Let's do the little bit more advanced stuff that will make us go to the RAG part. So we're going to ask again a question. So a question we asked just before. Hang on, let me just show you the question first. Hang on. Sorry, I missed that one. Question first. Sorry, I missed this one. The first thing we're going to do is an advanced question using what we call a system message. So that's very common in AI when you use chat models. And so in the first part, I mostly showed you that thanks to Langchain4J, you can easily switch between different implementations. Now we're going to start to understand also it gives you a lot of utilities that are very common. And instead of coding this manually, well, everything is provided for you. So the first thing we're going to see is what we call a system message. Again, very common. It's when you're a user, like you give it a question, give an explanation on how the Mona Lisa was painted. So that's what a user would do. But hidden to the user, we're going to give it a system message. So there's another message here that gives more information to the LLM, but which is hidden from the user. And we tell it, oh, I answer my questions in French in 100 words or less. So here we give it more context on how it's supposed to answer. So here again, a very good LLM like GPT-4o, you can here write crazy stuff, like you want the answer in Latin, in very weird languages. It will work. Something like Phys3 should work for something like, French is a common language. It's not as common as, I don't know, English, but still, for French, it should work. And so here we're giving some context, some more information to the LLM to answer the user's question. We'll see that let's say, the beginning of what we will do when we will do RAG. We will give it more context so it can answer you better. And so the answer we have here, the painting techniques, blah, 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 blah. So we do have an answer, which is correct from Phys3, but we can see it didn't answer us in French, and it probably answered us in 100 words. I'm not even sure. If I shift to GPT-4o, probably I will have a better answer. So that's also part of the work when you use LLMs. It's maybe depending on your configuration, depending on your LLM, maybe you will have a better answer or a worse answer, depending on what you choose. So let me run it here again, just to show you that it should work with GPT-4o, hopefully. Yeah, GPT-4o this time is answering me in French and in less than 100 words. So here we're seeing two things. First of all, the system message works. So we give more context to the LLM and the end user doesn't know it. And also when you have a better LLM, well, you have a better answer. But when you have a cheaper like Phys3, you have an answer which is not as good. Honestly, I was hoping to have some French. Sometimes it answers you in French. Well, maybe I can run it again. Yeah, because it's not, you have no guarantee of what it will answer. So sometimes you ask it several times and it might be better at some point. Yeah, this time, so I'm still, well, let me just check. Yeah, I'm with Phys3, as you can see. Oh, sorry, very interesting to have a look at the console here. So we can see here with asking Phys3, here is the system message, here is the user message, and then we're going to have the answer here. And the answer, so the answer is in French again, but probably more than 100 words. So again, Phys3, not too bad, not as good as GPT-4, but it's smaller and free. It's a decision to take. So we saw the system message. Now let's have a look at the second utility that is very useful. It's called memory. So I'm going first to ask it a question without memory. Hang on, let me switch. Yeah, I'm with Phys3, it's good. So let's have a look at that question. So that question is, where can you see this painting? And we just talked a lot about the Mona Lisa. So when you say, where can you see this painting, you're expecting it to answer, well, Mona Lisa is in the Louvre, it's in Paris, of course. And my answer is not going to be very good. It says, oh, you didn't specify which painting you are talking about. So here is some stuff. I'm trying to answer you, but I don't have the information. That's really important. And again, here we're going to see some of the utilities that are provided, but that's also going to make you better understand what's going to happen with the RAG part. So LLMs don't have a state. They don't remember that we talked about something earlier. It just forgot that we talked about the Mona Lisa. If you want it to work, you need to give it some memory. So that's going to be my next sample here. So let me click and then have a look at the code. So this time, we're going to give it a context. We're painting the Mona Lisa. That was our initial question. We're still going to ask the question, where can you see this painting? And we're going to have here a chat memory. So that's provided by Langchain4J. Again, they give you utilities that you will need. I don't imagine most people will create applications without any state. You always want to have a state when you have a chat. You want the system to remember the questions you asked earlier. And for that, you need to have something like this. So it's a simple chat. It remembers 20 messages. And it's asking the question again. And this time, it's working. The Mona Lisa by Leonardo da Vinci. It's in the Louvre Museum in Paris. So this time it worked because it got the memory. How is it working behind the scene? If we have a look at the logs, the user still posted that question, but this time we had some context. Like the previous question you had was, who painted the Mona Lisa? So it can understand that the painting we're talking about is the Mona Lisa. And you've got the answer for this. So all of this is extremely useful when you're building some advanced AI. I mean, advanced, I would say even normal AI. And as you can see here, Langchain4J gives you all the tooling to do that. And as you can see, most of those tricks are done by giving it more context, giving it more information. And that's basically what we're going to do in the last part on the RAG pattern. So let me go back to my slide. And let's have a look at why we want the RAG pattern. LLMs have two main limits. They've got a cutoff date. So this data was trained, I don't know, 1 year, 2 years, 3 years ago. So if you ask it who won the football match yesterday, it has absolutely no idea. And also, they don't have your internal company data. They don't have private data. It's trained on public data. So if you ask it, what's the benefits of my company, it doesn't know. It's inside your company. It's not public. So that's a big limitation for LLMs. And the trick is to fix this, is to do basically what we just did earlier with the memory or with the system prompt. We give it more context. We give it that information. And how can we give it to that information? Well, by using a database where we will store that information. So we need a database where we can ingest this data. That's what we call usually a vector database. We store the data inside that database. So there's a first part to ingest data into the database. And then we request the database to have, the context. And once we got the context, we need to mix data from the vector database with the LLM to get the final answer. That all seems very complicated. And again, this is where Langchain4J is really good at, because it gives you all of this out of the box. It gives you easy access to a lot of vector databases, a lot of LLMs, but we've already seen it before. And it gives you advanced features inside those vector databases. So if you have the time, have a look at hybrid search, semantic re-ranking. That's part of Azure AI Search. It's really good. I coded it, so I know. I coded the integration with Langchain4J because here it's the same thing with vector databases as with LLMs. You have some very good ones on the cloud, and we will check with Azure AI Search. You've got also some really nice one which run inside Docker, which we will also use. Like here, I'm going to use Qdant. Qdant is really good, runs locally inside Docker, but it won't have like hybrid search and semantic re-ranking like what we have in Azure AI Search. So it's basically the same story as what we just did. It's just another tool. And as all of this starts to be quite complex and we want to mix a vector search and an LLM, you really need something like Langchain4J to help you link all of this and make and orchestrate all of this so it all works together in a few lines of code, as you will see very soon. So first of all, let's have a look at vector databases. Let's have a look at how they work. So the vector database we're going to use is called Qdant. Inside Docker, if we have time, I'm not sure we'll have time, we can have a look at Azure AI Search. For what we're going to do, honestly, both are nearly as good because we do something simple. So inside Docker, if you've got Qdant running, here it is. You've got a dashboard. For the moment, everything should be empty. And so this is storing vectors. And let's have a look at what it is and how it works. And don't worry, it's going to be super simple. So first thing, I'm going to ingest some data in it. It's done. Let's have a look at what I did in the code. So I've got 6 items: a banana, a computer, an apple, a pizza, strawberry, and chess. I'm taking all of this data, and here I'm using some, again, Langchain4J API to use what we call an embedding model. So it's another type of LLM that's going to transform this text into vectors. We're going to have a look at them for real just afterwards. And we're basically telling it, well, all those vectors, when you got them, you put them into a store, an embedding store. Let's have a look at our embedding store configuration. So you remember we did the image model configuration, we did the chat model configuration. Now we're going to do the embedding store configuration. And so with Qrant, it's a little bit complex because you need to set up a vector store, a collection for it. So again, specific implementation, but it gives you back a vector store. Yeah. If you want to do the same with Azure AI Search, embedding store, here it is. A lot easier, but probably because AI Search is more, has got more features, and gives you back again an embedding store. So all of this, again, you've got different implementations, the same interface, and then when you use them with Langchain4J, you only use the interface, so you don't need to know the underlying stores, and also you can switch stores very easily. Again, this code works the same whether you run them inside Docker or on Azure. So what I did is that I sent those 6 items to my LLM, my embedding model. So it transforms them into vectors, and then I'm storing those vectors inside Qrant. If we have a look at Qrant here, we can see we got some data, 6 points of data. It's got 766 dimensions. So we're not talking 3 dimensions like in our world here. We're talking 766 dimensions, a lot more dimensions. By the way, with Azure AI Search, by default, I'm using 1,536 dimensions. It's even bigger. And what this does is that it transforms the world into those vectors with lots of dimensions. And then it's using a simple math calculation to see which vectors are closest to one another. So let's first have a look at a real example, and then let's look at the details. So my first question is going to be, I'm going to ask it a fruit. So as you can remember, we had banana, computer, apple, pizza, strawberry, and chess. So some of them are fruits, some are not. And the goal is to find the vectors, when those are transformed into vectors, which are closest to the fruit. So I'm doing the same thing here with my fruit. I use the embedding model that transforms the fruit into a vector. And then I'm asking my vector database, here Qrant, or it could be AI Search. I'm asking it, well, give me the 3, max results 3, give me the 3 results that are closest to a fruit here. And give me the answer and show me the answer, basically. Let's have a look at this here, creating the vector database. So it's giving me apple, strawberry, banana. So kind of, it worked. It found the 3 items that were closest to the fruit. Just let's have a look at the next demo because it gives you the vectors from the database. Like apple was transformed into this vector of 768 dimensions. You've got the strawberry somewhere. Well, they are all here. Like chess should be, strawberry should be here. Yeah, here it is. And it just does a math calculation to find the vectors which are closest to what you just asked. We can do some fun experiments here. Instead of asking a fruit, because that was easy, I love to ask it like laptop. So laptop, so you can see here you've got computer, so should be pretty close to laptop. Apple, well, Apple is a fruit, but they also do laptops. So Apple should be second. It's not as good as computer, but it's not too bad. And the third one should be pretty bad because nothing else is related to laptops. So let me restart this. And let's ask the question again, creating the vector database. Here it is. And so computer, apple, and strawberry. Why? I have no idea. It's probably far away from the others. So we saw our vector database makes it easy to look for some data and find the relevant data. That example was very simple. Now we're going to do something more realistic. And we're going to use the RAG pattern for real this time. So I want example number 10. So we're going to do some data ingestion again. Let me click on it here, advanced data ingestion. And here we're going to use the easy RAG model from Langchain4J. So it's got everything to help you to do the RAG pattern. So we're going to load document from a URL, and the document I used is this one. So it's a report on Microsoft activity. So you remember, so one of the issues with LLMs is that they have a cutoff date and you don't have your internal company data. So I try to take something a little bit recent. So that's our financial information from last year. So it's fairly recent, probably more recent than the LLMs annual report. And it's kind of internal data. I mean, this is public air, but you get the point. So lots of data about Microsoft. It's very big. You can see lots of data, lots of graphs. And typically, this is where you're going to want to have the RAG pattern. It's like, oh, find me some interesting information from this data. And there's a lot of it. So again, Langchain4J has got everything for you. It's got the same for loading PDFs, text files, everything. So here I'm just using a URL. If you want to test it with something else, well, just change the URL. And pass it. And it's going to embed it into our embedding store. If we look at the logs, it created lots of data. If we go back to Qdrant, we had 6 points. Now we've got 259. We've got all the data from Microsoft that came here. So it splitted the text into paragraphs, transformed them into vectors, sent them here, and they are stored here. Wonderful. And the last demo, we're going to do the RAG pattern on this. So our question is, how many people are employed by Microsoft in the US? That's a fairly precise question. And if you want, again, some recent data, you can only know it from the investors document that we just sent. And we're going to use what we call an assistant in Langchain4J. And we tell it, well, use the chat language model that we configured earlier. So it's v3 here in this case. Retrieve the content from our embedding store, so the vector stores that we configured earlier. So again, with Qdrant, you give us the last three, the best 3 results. If you give it too much results, at some point it confuses it also. So again, here you need a good vector database to have good answers here. And again, typically Azure AI Search is a very good one. And once you've got that very good data, you need a very good LLM to understand it and make sense of it. And again, OpenAI with GPT-4o is really good at this. Again, I'm running everything locally. So here I'm going to use Qdrant and v3. But honestly, we should have a good answer for this. So let's go back to our demo. Where is my demo? Here it is. And if we look at the logs, oh god. So we already had the answer. Where are my logs here? Oh, screen is too small. Here are the logs. So if we look at the logs, so we had how many people are employed by Microsoft in the US? That was our question. We transform them into embedding, so into some vectors. We send them to the vector store. That's so we got the answer from the vector store, sorry. And then we send it to v3 here. And v3, if you look at the question, that's the question we asked. But here, Langchain4J did something a little bit magical. It added answer using the following information. That's Langchain4J, which adds that. So again, you can do it manually. Maybe you have a better prompt, but EasyRAG from Langchain4J provides you with this out of the box with nothing to do. So again, if you do a hackathon, super nice, already done, being you in production. And maybe later, when you want to have something better, you will tweak this. But honestly, by default, it's quite good. And the answer we have, so we've got the 3 best paragraphs from the the investors' report coming from QGrant. So lots of data. And let's have a look at the answer we got. So according to provided information, Microsoft employs approximately 120,000 people in the US as of June the 30, 2023. Again, we're better than the cut-off dates. That's probably too recent. And it's also giving you some more information. Maybe if I ask it again, we can have some different answers, and so usually quite interesting. Yeah, this time it's showing like inside those 120,000 people, you've got people in operations, in LED, etc., etc. Very interesting. So here my RAG pattern works really well. And if we have a look again at the configuration we had, it's kind of easy. So we have a chat language model, which we configured earlier. We've got our content retriever, so using the embedding store, so using QGrant. We build it, and we ask it to answer, and that's all we need to do. So, like I would say, 3-4 lines of code, and some configuration from to connect to the vector stores and to the LLM. In this case, the chat model is Phi3, and the embedding store is that's QGrant. But QGrant was a little bit more complicated to set up. As it's RAG hack, and the goal is that you do some hackathon, you can just copy paste that code. You can go straight to the last, the last two tests. The last two, because number 10, you ingest data, you need to ingest data. So here you put your own data, maybe from a PDF file, maybe from something else. And then you copy paste here the easy RAG pattern from Langchain4J. And well, you will have honestly quite a good example. Then when you want to do something better, my advice is, so first try to have a better model. So maybe a better LLM, maybe a better embedding store. Also, yeah, I was using Nomics 3 to transform. Do I have access? Yeah. So yeah. I'm using this to transform my text into vectors. I like it because it's fast, but it's not super good. You have like this text ADAS 003, which is better, but not as fast. So usually it's a choice to make between performance and quality, and also what you're ready to pay, because at some point you go to the cloud. And so those which are better but less performant, well, cost you more money, of course. Once you decided all that, you also need to have a look at the amount of data you want. So again, here I'm giving it 3 results. So the more results you give, the more context it has. At some point, it's not good. Like it confuses it when it has too much data. But like if you give it 1, probably the answer won't be as good. But on the other hand, it will cost you less. Don't forget, when you pay for LLM, you pay for tokens, inputs and outputs. So if I go here, we can see that how many people are employed by Microsoft in the US. I gave it a lot of context, so I gave it a lot of tokens. So that's costing me some money. So maybe you want to limit that. So it's decisions to make between quality, performance, and cost, and that's not easy. For me, that's the main thing to do first. Once you have done this, maybe you can have a look at improving the RAG part of Langchain4J. Again, this is the easy RAG. There's lots of stuff you can tweak here if you go into the details. And so again, you can probably have a better result depending on your data. Oh yeah, sorry, I forgot to say also that depends on your data. Here, I got some good data that is read by this a nice HTML page. Maybe your data is not as good. Maybe it's stored somewhere else and it's not as easy to read. So here also, there's a lot to do to have good data before ingesting it. So there's a lot of work that you can do to improve this. But for a hackathon like this week, as you can see, I just take a URL, ingest it, easy RAG pattern. I got a rather good answer. I wouldn't do anything else for hackathon. I would use this as my proof of concept, as my, investor product, and then I would invest on it and improve it later. But like here, the first version is already good enough. If you want to play with it, we can start, or we can try other HTML files or try other questions. Like instead of people employed, we can ask it: is Xbox sales going well? I have no idea. And we'll see if it answers us correctly. We have 5 minutes left. I'm just having a look. Oh, sorry. We got the answer. So is Xbox doing well? Well, decrease in revenue, so not doing that well. Okay. Well, I love the Xbox, but I don't know that business that very well, so I have no idea if it's normal or not. Anyway, gives you the answer on something recent. Again, here's the rack pattern works very, very well. Do we have any questions? I'm not seeing any questions. No. Okay, well, if we don't have questions, I think maybe we can finish here. If you have late questions, we've got this discussion here on GitHub when you can ask your questions. I put as a demo code and everything. Oh, thank you for putting it into the chat. And if you want to play with my code, it's all here. I will maintain it in the next month because that's something I want to build on. Again, very easy to use the rack pattern with Langchain4J. Have a look at the other sessions, typically Spring AI, because it's a competing framework in Java. Both are very popular, built by very good teams. I know both of them very well. They're very good people, and they code some very cool products. Then I would say it's a matter of, I don't know, preference. Maybe in the framework you use, maybe you prefer Spring Boot or Quarkus, or maybe the type of code or in the community. I'm focusing on the Langchain4J community, but other people at Microsoft, typically Mark Eckler, are focusing on Spring AI. There's room for everybody, especially in open source. So have a look, and I would say enjoy that week of hackathon. And although super happy to get any feedback you have, if you use Langchain4J or Spring AI, anything on Java, on how easy it is to build a RAG app in Java, or how complicated it is, and all the issues you got. It's very important because that's also how we improve those products, both the open source products like Langchain4J, but also stuff like the Azure OpenAI SDK, or maybe even Azure OpenAI itself. There's lots to do. It's still very early days for AI, and I'm very interested to get any kind of feedback so we can improve and make things even easier and even better for everyone. So thank you so much. I think we can finish now, unless there are some questions.
Hey everyone, hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at akka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.
We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen. Today's event code is 23245. We'll see you at the next one.